All right, example 6 says x to the fourth plus 7x to the third plus 5x squared plus 30x. Remember, always check for GCF first, okay? If there's no number, then it's really 1. So numerical 1, 7, 5, and 30, they really don't have anything in common except 1. Now, x to the fourth, x to the third, x squared, x, they all have an x in common. So students, x is going to be your GCF. Then that means we are going to divide each and every term by x, just like this, okay? So that's x to the third, because x to the fourth divided by x, we are now 3x's left, plus 7x to the third divided by x. When you are dividing, you are actually subtracting the exponents, and x has an exponent of 1. So that's going to be 7x squared, plus 5x squared divided by x to the first, that's really 5x left. 30x divided by x is now just simply 30. So your final answer, students, will have this GCF in it. So we're gonna wait and we're gonna box that up. So now let's finish the rest of our factoring. We have 4 terms in the pink here. We are going to factor out the GCF of the first 2 terms. Remember that. So x to the third and 7x squared, they have x squared in common, okay? So x to the third divided by x squared, 7x squared divided by x squared, that's going to give us an x here, and then 7x squared divided by x is just now simply 7. This is a plus sign, drop down a plus. You are going to factor out a 5 because that's what 5x plus 30 have in common. So divide by positive 5. 5x divided by 5 is x. 30 divided by 5 is going to be a positive 6. Uh-oh, we have a problem. We thought we could factor, but look, when we did all the beautiful work, those 2 binomials are not the same. Therefore, we could not go further. Since we could not go further, our final answer is not in this form. Wah, wah, wah. So guys, your final answer could only be factor out a GCF, which is the first x that we took out. And then the leftover, which is x to the third, plus 7x squared, plus 5x, plus 30. And that is as far as we can go. Sometimes students think that, well, factor out the GCF is not factoring. That's not true. That is factoring, and we cannot go further because these 2 are not the same, so we cannot go further. All right, example number 6. That was 6, I'm sorry, 7. Okay, so example 7 says 10x to the third minus 4x squared plus 3 minus 12. So the numerical 10, 43, and 12, none of them have anything in common, so we don't have a greatest GCF on numerical. X to the third, x squared, x, and no x. So no GCF on all 4 terms. So we can go straight to now making your fence, just like this. First 2 terms, 10x to the third minus 40x squared, guys. We do have 10 in common. And then x to the third and x squared, we can definitely divide both of those with 10x squared each, just like that, okay? So GCF is kind of, think of it as what's the biggest number that I can divide into those things. So 10x to the third divided by 10x squared, that's going to have a remainder of x. Minus 40x squared divided by 10x squared, that's going to be a minus 4x, okay? The next 2 terms, we know that we have a 3 in common, so drop the plus sign down. So factor out a 3. Then go in and divide each of those things by positive 3. 3x divided by 3 is just 1x or just x. Negative 12 divided by 3 is now negative 4. Now check these right here. If they are identical, then that means we've did it. We factored them out. So that means we can write our answer like this, 2 sets, okay? So x minus 4, both of this right here, that's factor that out, okay? And that doesn't look like a minus. And there you go. Then we have 10x squared plus 3. That's your remaining terms, okay? That's your remaining term. That's what they go right there. And order doesn't matter. You can write 10x squared in the front. I'm sorry, 10x squared plus 3 in the front, and then the quantity of x minus 4 in the back. Last example is this one. 3x to the third minus 15 minus 40 plus 8x squared. Normally, when I see something like this, students, this is 4 terms, so it's a polynomial. But look at the exponents. You got third power, then you got 1 power here, then no power here, and then a second power here. So when I see stuff like this, I like to write them in order of exponents. Not because you have to, just because it's easier for us to not make errors, okay? 3, 8, this is 40. 3, 8, negative 15, and negative 40. They don't have any numerical in order. In common. We have x to the, oh, I didn't even copy this one down. Okay, 8x squared. X to the third, x squared, x, and no x. So no GCF for all 4 terms. But now we can make the fence. But we do have to check them before we make the fence. 3x to the third, 8x squared. We have an x squared in common, so we are going to factor that out. So divide this by x squared, divide this by x squared. 3x squared divided by x squared, you minus the exponent, so that's 3x. 8x squared divided by x squared, you minus the exponent, so therefore we just have the 8 left. Negative, you're going to take out a negative number. 15 and 40, we know 5 goes in there. Remember, we're taking out a negative 5. So that means, student, you're going to go in and divide by negative 5. Okay, so don't forget. And divide this by negative 5. So negative 15 divided by negative 5 is now a positive 3. And then 3x, because we did not divide by any negative, a value of x, which is divided by negative 5. Negative 40 divided by negative 5 is a positive 8. Okay, let's check. Are these binomials here identical? If they are, they will be able to be written here because we can factor that out, 3x plus 8. Then the leftovers, guys, they go in this second set of the parentheses. So x squared minus 5, and that's how we factor out 4 terms by grouping. Okay, so that's all of our examples, but students, here's a little box down here that I would like for you to write to yourself, you know, how to factor by grouping, like sort of bullets if you want, or write a question to yourself, something that you didn't understand so you can ask me in class.